the difference between two population mean, and x and y, they are independent, and also xy square, sigma x square and sigma y square, they are all known. And the second case is that we have the same thing, we are going to estimate the difference between two population mean. But in this case, sigma x square, sigma y square unknown, okay? And what do we have? We have another condition is that we know that sigma x square is equal to sigma y square, okay? Even though the population variance is not known, but we know that they are equal to each other. So in this case, what we're going to do, as we say, if you're going to estimate, okay, of course the best thing is that you know sigma x square. If you don't know sigma x square, then what you're going to use? You use xx square. The same thing, if you don't know sigma y square, then you use sy square as substitute. But now, we have one more condition because we know that sigma x square is equal to sigma y square. In this case, we have to use, and because now we know that we talk about two population, right? So you are not going to use only sigma x square or sigma y square or sx square or sy square because you are talking about two things. So in this case, what you're going to do, you have to use a pool sampling variance. It's called pool sampling variance. Okay? And what is that? It is denoted as ST square. P means 2. And what is this? This is equal to nx plus ny minus 2. And here what you have? You have nx minus 1 sx square plus ny minus 1 sy square. Okay? So what's the reason to use this one? Okay, what's the reason to use this one? Because this is an unbiased estimate. Okay, this is an unbiased estimate for sigma x squared. So let us say, because we know sigma x squared is equal to sigma y squared, and let it be sigma squared. Okay, and of course we talk about in the chapter of estimation, right? So if you want to know whether this one is an unbiased estimator or not, what you need to do, you're going to get expectation, right? So let us try to see if this is an unbiased estimator of sigma squared. So you're going to get expectation as p squared, and that is equal to expectation nx plus ny minus 2 nx minus 1 sx squared plus ny minus 1 sy squared. Okay? And here, because it is in the numerator and this is constant, so we can move it out. So you have 1 over nx plus ny minus 2 expectation, okay, nx minus 1 sx squared plus ny minus 1 sy squared. Okay? Questions? Okay, and what about sx squared? We already know that expectation of sx squared is equal to what? Sigma x squared. Sample variance is an unbiased estimator of population variance. So if you're going to get, this is constant, right? This is constant. So what you have? You have 1 over nx plus ny minus 2. And here you have nx minus 1 sigma squared plus ny minus 1 sigma squared. Okay? The reason is very simple because here it is an unbiased estimator of sigma x squared. And what is sigma x squared here? It is equal to sigma squared. Okay? So this is what you get. So then you have nx minus 1 sigma squared plus ny minus 1 sigma squared divided by nx minus ny minus 2. So what you get? Sigma square. Because here it is nx minus 1, here it is ny minus 1, so it is nx plus ny minus 2. Okay? So if you're going to estimate the difference between two population mean, and you know that sigma x unknown, sigma y square unknown, but sigma x square is equal to sigma y square. Of course, what you need to use? You need to use SP square. Okay, you need to use SP square. Okay, so here, this is the first case, right? This is the first case. I mean, here it is the first case. If you're going to estimate the mean, okay, of a population, you use this one. And suppose it is a normal distribution, okay? And now this is the difference between two population mean, okay? Difference between two population mean. Of course, you use this. And now this is the second case, okay? Sigma x square unknown, sigma y square unknown. This case, for the second case, you know sigma x square and also you know sigma y square. And xy independent, okay? Xy independent. And now for the third case, what you're going to do? The only thing you need to make a change is here. Sorry, is here, okay? Because you use different kind of variance, right? So what we're going to do? We're going to put down what's going on here. Okay. Okay, so here it is the same thing, okay? You are dealing with mu x minus mu y, right? And here the same thing, you have x bar minus y bar plus, okay, z alpha over 2. But here you have sp square and 1 over nx and 1 over ny, okay? And here you have x bar minus y bar minus z alpha over 2 and sp square 1 over nx 1 over ny. Okay. Questions? Of course, here we need to be a little bit more careful here. Because we say, you know, when sigma x square is a norm, sigma y square is a norm, you need to use sx square, sy square as substitute. And when you need to use sx square, sy square, what kind of distribution you need to use? You need to use t distribution. Okay, you need to use t distribution. But another point is, when the sample size is very large, what you're going to use? You use normal distribution. So in this case, if the sample size is very small, what you're going to do? You have to use t distribution, right? Okay, so here assume the sample size is very large. You use z distribution, that is fine. Okay, but when the sample size is not large, what you're going to do? You use t distribution. So here you have to have t alpha over 2, and here is t alpha over 2. The same thing, okay? In this case, if sigma x square is not known, what you're going to do? You have to use t distribution. So for the first case, if sigma x is not known, you have to use t distribution, x bar minus t alpha over 2, okay? And sx square divided by n, mu x, x bar plus t alpha over 2, and sx square divided by n. Okay? So this is when when the sigma x square is a known, right? In this case, we say sigma x is known, so we can use sigma x square and sigma y square, right? And here is a known. So generally, if the sample size is large, that's fine, use Z distribution. But when the sample size is small, you have to use T distribution. But because at this point, we haven't talked about anything about T distribution, so we will, discuss the T distribution in more details next week. And also next week, we're going to cover chi-square distribution. So if you have time, please do some homework ahead, do some reading, preview T distribution and chi-square distribution. Okay, any questions? But, so far the population we talk about, it is all independent, okay? It is all independent. And now we are going to discuss something that is not independent. So for example, you grow apple, okay? If you grow apple, of course you have to take it to the market to sell. And so the market, when you pick up the apple, there is weight there. But when you transport the apple to the market, the weight may be different. So in this case, you are talking about the same apple, but so the first thing is that the population is not independent, okay? The population is not independent. And so you have to use a different way to deal with it, okay? But let us make sure that everything is fine here. Have you put down the things you need to do? And also here, okay? We are going to talk about the same thing, the difference between two population means, but in this case, these two populations are related, okay? They are not independent. So we have, let us say, you pick up one apple at the, in your farm, okay? And then the weight of apple here is when they reach the market. So you have two populations, but actually it is the same thing, right? So they are not independent. But of course there may be some difference. Still you are interested in knowing what's the difference between the population mean, okay? So for example, if the weight loss is too much, okay? If the weight loss is too much, then you have to try to invent some way that can preserve the weight. Because for the apple or pigs, or cows, right? If you're going to sell it, it is by the weight. So you want to get something done, to prevent any weight loss. So here you are required to know what is difference between. You are going to investigate what's the difference between mu x and mu y, right? But in this case, they are not. Okay, they are not independent. So how are you going to do that? So for example, x, you have x1, x2, xnx, right? And here you have y1, y2, yn1, right? So in this case, actually, you're going to do it in pairs. What means in pairs? In pairs, that means, of course, you want to compare the weight of this apple, okay, when it is in your farm and then when it is at the market. So actually, we will invent a new variable. So this new variable is c. Okay, and what is c? x1 minus y1. Okay, and x2 minus y2, etc. x. So in this case, the number should be the same, right? Okay, in this case, so the number should be the same, okay? So xn minus yn, okay? So of course, you are going to estimate d bar. D bar is what? X bar minus y bar, right? Okay, x bar minus y bar. And of course, you need to know, because in this case, if it is x, you need to know sigma x, and if it is y, you need to know sigma y, right? And here, you are going to get sigma d. And what is sigma d? So let us say sigma d squared. 1 over n minus 1 dimension, right? d minus d bar squared. Okay? So in this case, when they are not independent, okay, when they are not independent, you treat them as one variable, okay? So you try to invent, you get a new variable called d. D means the difference between x1, y1, okay, x2, y2, okay, xn, yn. And so here is what you get. And so in this case, in terms of the formula, what is the formula here? The formula is, okay, of course it is going to be mu d. And mu d is mu x minus mu y, right? And then here you have d bar. So let me erase some part of it to avoid any confusion. And plus z alpha over 2, and then you have, of course, suppose you know. And here you have d bar minus z alpha over 2 sigma d square over n. So the same thing, in this case we assume sigma d square is known, right? We assume sigma d square is known. If sigma d square is unknown, what you're going to do? Z alpha over 2 will be changed to T alpha over 2, okay? Okay, basically that's what we talk about here. Any questions? Any questions? Okay, so here it is population mean, okay? The difference between two population mean, but sigma x squared known, sigma y squared known, and xy independent. In this case, the estimation between two population mean, right? The difference of two population mean. Sigma x unknown, sigma y squared unknown, and sigma x squared equal to sigma y squared. So in this case, you use poor sampling variance, okay? Poor sampling variance. Okay, and here it is about two population, okay? Two population. They are not independent, okay? Not independent. And in this case, you do it this way, okay? You do it this way. Okay, and here is the case that when sigma x squared population variance is unknown, what you use? You use sample variance. And then what kind of distribution you're going to use? You're going to use T distribution, okay? So here is the general discussion of the estimation between two population mean, okay? Two population mean. And now we're going to talk about the difference between two population proportion. And proportion is P, okay? Basically, we are talking about binomial distribution in this case. Okay? So in this case, we are talking about P, okay? The population proportion. Any questions? Any questions? So basically, it's all the same. Basically, it is all the same. The only difference is here, you no longer use mu x. Okay, you no longer use mu x. What do you use? You use P. Okay, you use P. And oftentimes we don't use P bar. We use P prime. Okay, so here we use P prime. Okay. Okay, and in this case, you're going to assume that, you know, PQ is known or unknown. Okay, so let us get something. Hold on for a few seconds. Okay. So in this case, we're going to assume, because we use normal distribution and we have the variance known, right? So here you're going to have PQ. PQ and PQ, okay? Okay, and what about here? What about here? So you have two population proportion, right? So you have P1 minus P2. Okay, P1 minus P2, okay? And then the same thing here, you're going to have P1 prime minus P2 prime, okay? And here you have P1 prime minus P2 prime, okay? Basically, you know, all the procedures to derive the formula is the same, okay? But of course here will be different, okay? Here it will be different. What is that? So it will be P1 Q1 divided by N1 and P2 Q2 divided by N2, okay? Okay, the same thing, right? Here you have P1 Q1 divided by N1, P2 Q2 divided by N2, okay? But for this part, we don't want to deal with it, okay? Basically, you're going to get the same thing, okay? Basically, you're going to get the same thing. So this is what we have discussed so far. Next week, we're going to talk about t-distribution and chi-square distribution. And also, if we got some more time, we will discuss some more problem sets, okay? That's for today.